A very warm welcome to all of you to today's session where we're going to discuss what is NAT Gateway. NAT stands for Network Address Translation. So we're going to understand what is the importance of NAT Gateway in the AWS environment. Okay, so as you see here, a NAT gateway is an AWS managed service. That means we do not have to do anything in terms of the um, routing and the configuration part in the backend. AWS manages all that. We just have to provision it and connect our resources to it. So it is a AWS managed service that enables instances in a private subnet to initiate outbound internet connections while preventing inbound access from the internet. So let's say that, as we have seen in previous sessions, let's say that you have a virtual private cloud. As we see here, you have a VPC where you have your large network and where you have deployed other sub networks, other smaller networks where you have different resources belonging to your organization, be it servers, databases, and you have kept it separately in terms of the confidentiality of the information that you have. So let's say that you have certain servers which you want to expose to the internet. We keep it in the public subnet, but the servers and the databases which are which have confidential data, you want to keep it in the private subnet, right? So that's how we differentiate the data in terms of subnet. Now, in this case, all the internet facing servers are in the public subnet. Now, let's say in case you have a server in the private subnet. So, of course, the public subnet means that it has access to the internet. Private subnet does not have access to the internet, right? So, let's say that we have a server or a database here in the private subnet. Now, this server needs an update from the internet, right? So let's say that it's a Microsoft server or it's a Linux OS or whatever it is, and it needs to update from the internet. It needs to download the latest updates from the internet. Because we have kept it in the private subnet, how would it gain access to the internet to download those updates? That's one important point. So let's say that the same server, if it was in the public subnet, it would be able to access the internet, right? So the public subnet server would be able to access the internet through the internet gateway. So let's say that the internet is somewhere here. It can go to the internet gateway, which we define in the route table. We mentioned in the route table that for the public subnet server to connect to the internet, it has to go to the internet gateway, and from there it can connect to the internet, right? So once we define that path in the route table of the public subnet, then the server in the public subnet can access the internet through the internet gateway. All right. Now, we have not defined that same path for the private subnet, right? That's the whole purpose behind keeping it private. The difference between the public subnet and private subnet is we do not connect the private subnet to the internet. Now, when you have that server or the database in the private subnet, there are certain cases where you might want it to access the internet and download certain updates. In that case, how would you do it? So for you to understand that, you need to understand one concept, that the server in the public subnet is has two-way internet uh, connectivity going on. So for example, the traffic is initiated in two ways. So first, traffic is initiated from outside. So let's say that someone is on over the internet, someone wants to access the website or the application which is hosted on the server in the public subnet. So they will use an endpoint and they'll connect to the website. So let's say something like the website hosted on the public server is something like www.google.com, right? So when they access that domain, they will, through the internet gateway, come in and they will access this particular server, right? So, and once they access this server will return whatever they have requested to that user. So the traffic is initiated from outside the VPC by a user, and that connection comes to the server, and then the return traffic goes to the user, right? So the traffic is initiated from outside the VPC. Same way, if this public server, let's say that it's a Windows server, Linux server, whatever it is, if it wants to download certain operating system update or some application update, whatever, from the internet, this server itself will initiate a connection to the internet through the internet gateway, right? So it will, let's say if it's a Windows operating system, it will initiate a connection to the update a server of Microsoft, right? So it will go ahead through the internet gateway, it will connect to the Microsoft server, and then from there it will get the update, and then it will download that update to the server, right? So in this case, the connection is being initiated from within the VPC, within the subnet by the server, right? By the public facing server. So in this case, it can easily do that because it has access to the internet gateway. Now, let's say that you imagine the similar situation for the private subnet. Okay, now we do not have any connectivity to the internet gateway for the private subnet. It does not have that connectivity. So if there is a person on the internet and they want to access this database or this private server directly, they will never be able to do that because there is no connectivity of the private subnet to the internet gateway, right? So they will never be able to initiate a connection to the private subnet. So that's the whole purpose of keeping it private, right? So that nobody can, no hacker or no attacker from the internet can attack our confidential servers or private servers, right? So the con of that, or the drawback of that, is our private server also cannot initiate any traffic to the internet because it has to go through the internet gateway. It does not have path to the internet gateway, right? So it does not. So if we give path to the internet gateway, if we do want to download certain updates and we let's say we give it a path to the internet gateway, then what will happen? It will be able to initiate a connection to the internet and access and download the updates, but it also opens up the path for any attacker or the hackers to come in and access our private subnet servers, right? So that's why we do not want to do that. So whenever you have an internet gateway, the key point to understand is that internet gateway allows you two-way two-way traffic initiation, right? Two-way traffic initiation. What does that mean? Just what we understood just now, that the traffic can be initiated from within the VPC. That means by the server, it can initiate a request to download a certain update, and then that update comes in. Or the traffic can also be initiated by a user from the internet outside of the VPC, and they can come in and they can access the data on the server within the VPC. Right, so this is the two ways of initiation, two sides from where the traffic can be initiated. But in this case, in the case of the private subnet, what do we want? We want the traffic to be initiated by the private server, right? We want it to be we want it to be initiating the connection for downloading certain updates. It should be allowed, right? It should be allowed, but no one should be able to access the server from outside, right? So that's why I'm drawing it as a red. No one should be able to initiate a connection from outside to inside, right? So we know that internet connectivity, internet gateway, this router, this virtual router allows connectivity both ways. That's why we cannot use internet gateway to fulfill the requirement of the private server, where it can initiate a connection to the outside, but no one should be able to access it from outside to inside, right? And that's why in this place, in this kind of a scenario, where we don't want anyone to access from outside to inside, but we want the server to access outside from inside, in that case we use something called as a NAT gateway, right? So it's very similar to the internet gateway, but it works along with the internet gateway. As such, it is not a separate entity. It cannot function separately. So the NAT gateway is a device which allows you to create a connection which can allow traffic only from inside the VPC to outside, but won't allow traffic from outside to inside. So we'll see that practically as well. So we will create a NAT gateway, but one thing to notice, and a NAT gateway itself always requires a public IP, a public IP address, right? So if you remember, we know that a public subnet server would use a public IP to connect to the internet, right? But we never assign a public IP to the server in the private subnet because we don't want it to connect to the internet. So our private server here, our private server will not have a public IP, right? But to connect to the internet, it would require a public IP. So what do? we create a NAT gateway, right? And the NAT gateway is created in the public subnet always, right? The NAT gateway is always created in the public subnet. Why is that? Because when we create the NAT gateway in the public subnet, we can assign a public IP to it, and when we assign a public IP to it, it is able to connect to the internet. All right, so that's why we need our NAT gateway to be in the public subnet. So once we connect, once we create our NAT gateway, we are able to um, create a path for the private server to connect to the internet. So let's see how do we do that, and then we will practically see how that entire path is being created. Okay, so once before we create the NAT gateway, once again we'll quickly run through a few important things about the NAT gateway. First of all, as we saw, it is used to initiate outbound internet connection while preventing inbound access from the internet. Okay, and then majorly it is used for tasks like downloading operating system and application updates, accessing external APIs, communicating with other services, etc. Right? And then some key points about NAT Gateway, as we just saw, is that it is always deployed in the public subnet along with the backend route to the internet gateway. So we connect our private server to the NAT gateway, but the NAT gateway again goes to the internet via the internet gateway itself, right? So in the backend, they are again connected. Now we always create a route table um, for the private subnet, and in the private subnet route table we mention that if you want to go to the internet, go via the NAT gateway. So just like for the public subnet, we created an internet gateway and we gave a path in the route table saying that if you want to go to the internet, go through the internet gateway. Here we give the path as NAT gateway. All right. Now, we'll see a few more things about that again, but let's now go ahead to our console, AWS console, and we'll create this and see how it works. So just to quickly understand how NAT gateway works, I've already created a VPC. So this is the VPC that we've used before. This is my Mumbai VPC. So this is the CIDR range that we are using. Under the Mumbai VPC, I have multiple subnets. One is a private subnet and one is a public subnet. Now, why is it private and a public subnet? Because the public subnet, if you see, is connected to a route table. Okay, and in the route table I have a path to the internet. Okay, so as we saw, when you are creating the subnets, all the subnets are created in the same way. What makes it a public subnet or a private subnet is the fact whether it is connected to the internet through the internet gateway or not, right? Now in this case, if you see, I have all clearly given a path to the internet uh, through the internet gateway, IGW internet gateway. So that means this is a public subnet, right? That's why I've named it as a public subnet. In the private subnet, if I go to the private subnet, you'll see that if I go to route table, it only has the local path so far in the default route table. So I've not added any new path to the internet. So it only has the VPC, internal local IP. So it can connect to the other servers within the other subnets within the VPC itself. So it does not have any path to the internet. That's why it's called as a private subnet. So these are the two route tables we have so far. So this is the public route table that I've created, and then we have the default route table for the private subnet. Now we have created one internet gateway which is attached to the Mumbai VPC that we have. So through this we are connecting to the internet. So this is the overall infrastructure we have right now. Now what we are going to do is we are going to create these two EC2 servers. So these two are EC2 servers. So we will create the EC2 servers, and then we will connect to the EC2 servers, and then we'll check the internet connectivity. Okay, so before that we will also create the NAT gateway. Okay, so this is my public server, and this is my private server. So that means my public server will have a public IP address. My private server will not have a public IP address. Okay, so first now we'll create both the servers, then we'll create the NAT gateway, and then we'll see how do we connect to the internet. So first let's go ahead and create the public server. So I come here and I search for EC2, through which we'll create our server. So I'll click on launch instance and we'll create a Windows server so that we can understand the graphical user interface well. So I'm just going to name it simply as a public server, and then I'm going to choose a Windows operating system. I'm going to choose here Windows 2022 so that I can get t2.micro instance type, which is free to use. And then create a key pair. Let's call this as Windows key. You can reuse the same key for multiple servers also. So it's downloaded on my system now. Now here in the network settings, I want to place my public server in the public subnet, right? So I choose the VPC, then I choose my public subnet. So just to keep things clear and avoid any confusion, I've deleted the default VPC from my Mumbai region. Okay, that's why you'll see only one VPC, which is the Mumbai VPC, the custom CIDR range that I've selected here. So I choose Mumbai VPC, then I choose the public subnet where I want to place it. And because this is the public server I'm creating, every time you're creating a public server, you would require a public IP address, and that's what I'm assigning to the server. So I'm assigning a public IP address to it. Now in the security group, I want to just create a security group. So I'm just going to call it demo SG. So here I want the rule to be RDP. I'm keeping it as anywhere, but in terms of whenever you're working in enterprise level and all that, you will make sure that you're assigning specific source only the systems from where you want to access it. But here I'm just using it as anywhere because we're just practicing. Okay, so this security group, we are going to create multiple rules. So here I'm selecting RDP because we'll be remotely accessing our server through RDP. Then I add another rule. So let's say that I'm adding here HTTP, excuse me, and I'm saying anywhere because we'll be testing the internet connectivity, right? And then this is my storage disk. That's all, and I'm going to launch this instance, and then we'll connect to it after some time. Then I'm also going to launch my private server so that we'll wait for both of them to come up very soon. Okay, so I'll click on launch instances. I'm going to name this as my private server. So because this is going to be our private server, of course we'll launch it in our private subnet, which does not have access to the internet. Okay, so I'm just again selecting this 2022, and I'm selecting t2.micro here. I'm selecting the key that I just created a while back. Then I come to the network section, I select Mumbai VPC, and here I select private. And because I'm keeping it in the private subnet, I'm not going to assign a public IP address to it. So in this case, as we are learning NAT gateway, we are not assigning public IP to the private server, but still we will be able to access the internet through the NAT gateway, right? And when when we access the internet through the NAT gateway, at that time the NAT gateway will assign a temporary public IP address to our private server. So how does it do that? We'll see now. Okay, so I'm just going to select the existing security group that we just created a while back, and then I scroll down and I click on launch instance. So right now we have two servers coming up. One is a public server and one is a private server. Okay, so these two servers are now coming up. So we'll just wait. So just to keep everything in line with what we have seen here, we have one VPC, we had a public subnet, we had a private subnet, we have an internet gateway. The public subnet, through its route table, right? So the public subnet has a route table in which we have defined the path to the internet. We have given the path to the internet via the internet gateway. Okay, so we have created a route table, public route table. This public route table is associated to our public subnet, right? And this public route table has the path to the internet through the internet gateway, and the internet gateway is of course connected to the internet. Okay, so I'm just drawing this as a representation of the internet. Right. So far we have seen this. Now what we are going to do is we are going to create our NAT gateway. So while our servers are coming up, we will also create the NAT gateway. So creation of NAT gateway is a very simple process. Just like when we created the internet gateway, we just gave it a name, and it automatically configures and provisions everything in the background. Same way we can create a NAT gateway as well. So to create a NAT gateway, we come to the VPC console first. So this is my VPC page. So on the left hand side, where you have the VPC, subnet, route table, internet gateway, etc., you also have the NAT gateway. Okay, so I click on NAT gateway, and it says no NAT gateways found. Okay, so when we compare it with this particular diagram, we have to keep in mind that when you create a NAT gateway, right? When you create a NAT gateway, the NAT gateway is always placed in the public subnet. Okay, it's always placed in the public subnet. Why? Because the NAT gateway itself will have a public IP address, and just to make sure that the public IP address should not change, it's an elastic IP address. So in AWS, whenever you have a static public IP, a static public IP means a public IP which does not change, which has been permanently assigned to that particular resource. That is a public static public IP, right? So in AWS, it is called as elastic public IP, that is assigned to NAT gateway, and that is what NAT gateway uses. Okay, so on this page, we click on create NAT gateway, and to create NAT gateway, there are a few details that you need to fill in. It says a NAT gateway is a highly available managed network address translation service that instances in private subnets can use to connect to services in other VPCs. So the prime purpose of the NAT gateway is to ensure that the instances in the private subnets can use it to connect to other services or the internet and so on. Okay, so first we give the NAT gateway a name. So let me call it as a Mumbai NAT gateway, just because we are in the Mumbai VPC at present. And then, as I told you, it asks us select a subnet in which to create the NAT gateway. Okay, so this is not it's not asking for a subnet which you want to enable to access the internet. That's not what it is asking. It is asking select a subnet in which to create the NAT gateway. So if you refer to the diagram that we just understood, it we want to create the NAT gateway in a public subnet. Now, where would the confusion arise if you have multiple subnets, which is very common in corporates and enterprise networks? Let's say you have one VPC and there you have 5 or 6 different public subnets. You have to be very sure in which particular public subnet you want to place it in, right? So right now we have only one public subnet. So if I select this, it will show me multiple subnets. I have to select the public subnet that I have. Okay, so I want to place my NAT gateway in this public subnet. And then I scroll down, and it is asking select a connectivity type for the NAT gateway. So in this particular case, I want to use this NAT gateway to connect to the internet, right? That's what we discussed. But yes, there will be certain instances where you can use it for network translation within your network itself. At present, we are going to use it to connect to the internet. Okay, and that's why because we are connecting to the internet, it requires a public static IP address. That's why we need to assign an elastic IP to it. So it says assign an elastic IP to the NAT gateway. So if you already have an elastic IP on your account, you can assign that. If you do not have it, you can just click on allocate elastic IP, and it will assign an IP address from the AWS pool that they have. Okay, so here if you see, it has assigned an IP starting with 13. So 13.202.8.247, that's what it has assigned to us, which is a public IP. And because it says that it is an elastic IP, that means this IP has been permanently associated with our NAT gateway. Okay, so now whenever until I use this NAT gateway, this IP will be with me. If I delete the NAT gateway, okay, this is a very important point that you need to keep in mind. If I delete the NAT gateway, the IP address that I have taken will remain in my account. Okay, it will remain in my account, and until I release that elastic IP from my account, I will be charged for that IP address. Okay, as long as I'm using it along with the NAT gateway, I'm not charged specifically for the elastic IP. I'm only charged for the NAT gateway service and the data that passes through it. But if I delete the NAT gateway, I need to ensure that I release the elastic IP address so that I don't separately get charged for it even while I'm not using it, right? So how did we create the NAT gateway? We created the NAT gateway by giving it a name. We selected the public subnet in which I want to place the NAT gateway. Then I want to make sure that I assign an elastic IP address to it, elastic public IP address to it, and then I just click on create NAT gateway. It takes some time to be provisioned. So if you see here, the state shows as pending, so it's still being created. So how do you release your elastic IP? You can see that in the meanwhile. So on the left hand side, just above NAT gateway, if you see here, it says elastic IPs, right? So this is the exact elastic IP that we were allocated just now. A while later, you'll see that it will show that it is associated with our NAT gateway. Okay, once the provisioning is complete. So once if you delete the NAT gateway, this elastic IP will still be here. Okay, so what you need to do is just come here, select this, click on actions and say release elastic IP. So when you release the elastic IP, it will be released from your account. Okay, so we'll just wait for the NAT gateway to be provisioned. Once it is provisioned, we will see how to proceed. So for now, let's get back to our instances. Okay, so now what we have done is we have created two instances and we have created the NAT gateway as well. Now, if I look at our diagram, you'll see that the representation is such that my internet gateway allows internet access from both the sides, right? So internet gateway allows internet to be initiated from inside the VPC also and externally also. But NAT gateway allows the internet to be initiated only from inside going outside. Of course, if the request is initiated from within the VPC by a server, of course, the response to that request will be allowed to come in. Okay, because the request is initiated by the server within, right? So if it requests for an update, of course, the request for that update, the return traffic will be allowed to come in. But if someone from outside tries to access my server through the NAT gateway, that will never be allowed. That's why I've shown that arrow in red over the NAT gateway. It will not allow any initiation of traffic from outside towards my private server. Okay, so now what now how do we access the public server, right? So how do we access the public server? We access the public server from the internet through the internet gateway, and we access the public server, right? Now, can I access the private server in any way through the internet? No, right? Because that is of course prohibited. We don't want anyone to access our private server from outside. That's the very reason we've kept it disconnected from the internet. So how do we access the private server? So it's very simple. You first access your public server. So from the internet, because I am also accessing my servers from the internet, right? So I'm somewhere over here. So first I access the public server through the internet, okay, which we'll see now. And then because my public server and private server, because both of them are within the same VPC, they are local to each other, right? And because they are within the same VPC, as I just showed the path in the route table, from the public server itself, you can RDP or you can remotely access the private server because they are in the same network, right? Although they are in this different subnetworks, they are within the overall VPC, same VPC, right? So how do we access the private server? No one from outside can access it, but we can go into the public server, and because they are both local to each other, from the public server I can access the private server. So once we do that, we will see from the private server can we access the internet or not. Okay, so when I go into the private server from the public server, of course I'm accessing it locally. I'm not accessing the private server directly from the internet. That's why there is no connectivity between the private server and the internet. There is there is no internet connectivity, right? So how do we bring that internet connectivity to the private server? That's what we are going to see. So first step, what are we doing now? We are going to access the public server from the internet. Okay, so from the internet we will access the public server. All right, so we have both our servers running up and running now. So I'm going to access our public server here. So I click on my public server link here. So you see my server is up. So I click on connect and I select this RDP client. So if you remember, in the security group, we have already allowed the RDP port. So I click on this. Now I click on download remote desktop file. So it will just download this file for me, where it will have all the IP addresses and everything filled in for me already. Then I click on connect. And to connect, we need a password, right? So how do we get the password? I click on this get password. I upload the key file that we just created a while ago. Okay, so I decrypt it and I get the password and I apply the password here. All right, and now I'm able to access my public server. So this is the public server that I have. So if you see here, the IP address shows as 13.235.244.225. If I go in and check the IP address, this is what you'll see here. So here, right? So we are accessing this server through a feature called as Windows Remote Desktop Connection, which uses the Remote Desktop Protocol, which is RDP, right? And through this particular protocol, we are able to access our public server because it has a public IP address. So through the internet, we are able to access this server. But the server, so if I show it to you in the diagram, right now we have, from the internet we have reached this particular server, right? So from the internet we have reached this particular server through the internet gateway, right? So through the internet gateway we have reached this particular server. Now from here, from this public server, we're going to access our private server. So how will we do that? We require the private IP address of the private server. Okay, so I go into my public server. So this is my public server, and then I open here, I select remote desktop protocol, RDP. Okay, so this is my public server. Here I open RDP or remote desktop connection. Now here I need to put in my private IP address of the private server. Okay, so how will I get that? I get it from my console. So I go to instances again on my AWS console. I select the server, the private server. I click on, so I can access, I cannot connect to it directly here because if you see, I don't have the public IP address for the private server. Okay, so what do? I copy this particular IP address. Okay, I copy the private IP address of my private server. Then I go to my public server into which I'm logged in, and I put that password in here. All right, and I click on connect. Now because these two servers are connected locally, it will ask me for the username and password to connect to the private server within the public server itself. Okay, so how do I get the username and password? So I just click on connect again. I go to RDP. So this is the private server. See here, private server. I come to the connect RDP client page, and here if you see, this is the username, administrator. So I can copy this, I can put that here, administrator. Okay, and how do I get the password? The same way we got it a while ago. So I click on get password. I upload the private key that we just downloaded, and I click on decrypt password, and you see I get the password here. Okay, and I paste it here, and you see I'm now able to access our private server from our public server. So this is my public server, and this is my private server within the public server. And if you see, the IP address also shows as 10.0.2.105, which is a private server IP address. Okay, so what have we done here? If I show it in the diagram, we have connected to the private server from here, from the public server. Okay, and now we are going to check whether we have internet access or not. So let's just wait for this server to come up and then we'll check that. Right, so now both our servers are up. We are logged into our public server. We are also logged into our private server. So first we'll check whether on our public server we are able to access the internet or not. So very simple answer to that is yes, we should be able to access the public server internet, right? Why? Because we accessed the public server through the internet, right? So it should have internet access. So let's see if it works or not. So if you see on the public server, which mentions here public server 13.235, I am able to access Google. If even if I go to any of these pages, you'll see that it is loading. So we are on the internet is working fine, right? But at the same time, let's see whether this internet works on our private server or not, right? So from the public server, we have accessed our private server also. So this is the private server. So let's check whether we are able to access the internet on the private server. So I open up the Internet Explorer Edge browser. Okay, so this is our private server. So here I'm just going to check whether we are able to access Google or not. So you can see here the IP address is 10.0.2.105, which is our private server. And if you see, now we are not able to access the internet here at all. No matter what site I put in, it will not allow us to access the internet. Okay, so what is the reason? Because first thing, this server does not have any public IP address. It does not have any path to the internet through the internet gateway or anything. Whereas the server that we access, this private server through this public server, it has access to the internet. Any link that I click on, it loads the internet. Okay, so now as we discussed in the beginning of our this video, we need to make sure that our private server here, the private server should be able to access the internet. Okay, the private server should be able to access the internet. So how do we do that? We do that by creating our NAT gateway. Okay, so we have already created the NAT gateway. If I come here, you'll see that if I refresh it, you'll see that this NAT gateway is available. Right now, just like when we create the internet gateway, we connect the internet gateway. That means we attach the internet gateway to the VPC, and then we need to give a path to the internet gateway through the route table. Okay, so although we have the subnet needs to be told to connect to the internet through the internet gateway via the route table, right? So through the route table route, we tell the subnet to connect to the internet. Same way, although we have the NAT gateway, right? Although we have the NAT gateway, we need to tell the private subnet that in order to connect to the internet, go through the NAT gateway. If we tell it to go via the internet gateway, it won't serve any purpose. The subnet will just end up being a public subnet then, right? And then all our confidential databases and everything will be exposed to the internet. So we don't want to do that. We want to ask the private subnet to connect to the internet through the NAT gateway, right? Why is that? So that only the connection from inside will be let outside, nothing from outside will be let in, right? So what do we do? How do we do that? We create a route table for the private subnet, right? And we call it the private route table. We call it the private route table, private RT. And here we mention we create a route saying that if you want to connect to the internet, go through the NAT gateway, right? So just like we told the public subnet to go through the internet gateway, we tell the private subnet, private server, to go to the internet through the NAT gateway, right? So once it does that, it will be able to connect to the internet, right? So just before we do that, if you see here, when I click on NAT gateway, you'll see that the NAT gateway has an IP address associated with it, which we assigned to it when we were creating the NAT gateway, right? Now the NAT gateway will allow every single server that connects to it and goes to the internet, it will allow it to use the same public IP address, right? So just a while ago I showed to you, if I go to the instances, right, if I select the private server, you see the private server has only a private IP, it does not have a public IP at all, whereas my public server has a public IP address, right? My private server does not have a public IP. So that's why the NAT gateway assigns its own public IP address to the private server to access the internet, which I will show to you in some time. Okay. Now, doesn't matter how many private servers are there in the subnet, or as many number of private servers are connecting to the NAT gateway, every private server will end up using the same IP address assigned to the NAT gateway. They will all use the same NAT gateway IP address. Because it's a NAT gateway, it will just translate the addresses, it will translate the IPs, and it will create multiple sessions for all the servers, and it will manage the uh, traffic flow that way. So it will assign same IP address to all the servers, and it will have multiple sessions to manage that properly. Okay, so let's see. Now we are going to create a route table for the private subnet. Okay, so for the private subnet, we'll create a route table, and then we'll associate that route table with the private subnet so that the server will have a path to the internet through the NAT gateway. So let's see how to do that. So I come here to the route tables and I click on create route table, and I'm going to create a route table called as private RT. Right, I'm going to select the VPC where we are going to place it, and I'm just going to say create route table. So I've told you before, whenever we are creating a route table, there are two major things that we need to do. First, you need to associate that route table with a particular subnet that you want, right? Without associating, it will not be applicable for any subnet. So I click on subnet associations, and right now this route table is not associated with any subnet. So I click on edit subnet associations, and I connect it to the private subnet. I associate it with the private subnet, and I click on save associations. Now my route table is connected or associated with the private subnet. What's the next thing we need to do? We create a route. So two things we need to do whenever we are creating a route table. You associate it with the specific subnet you want, and then you create the route. So I come here. If I click on subnet associations, it now shows that I'm connected, associated with the private subnet. Now I go to the route. This is the local route within the VPC. Now we will create a route for the internet. Okay, so I click on edit routes. I click on add route, and here I have the path to the internet. So I select internet. Then here we will select NAT gateway. So in the case of the public subnet, we had selected internet gateway. Here we will select NAT gateway. So I select NAT gateway, and I select the NAT gateway that we had created. All right, and I click on save changes. So now the private subnet knows that if it needs to go to the internet, it will have to go through the NAT gateway. So what has happened? We have created a path from the private server, or rather I should say the private subnet, to the NAT gateway. And again, as I told you, in the backend, the NAT gateway is also connected to the internet gateway. That means the private server can now very easily, via the NAT gateway and the internet gateway, go to the internet, right, and receive the update. So let's check that. Now that we have connected it to the NAT gateway, if you see, all I have to do is just refresh this page on the private server, right? So if you see here 10.0.2.104.105, this is my private server, this is my public server. On the private server, all I have to do is just refresh this page, and we will be able to access the internet. See here. And you see, I just refresh the page and I'm able to access the internet. Let me see if I'm able to access the latest news and all. And you see here, we are able to access it. In the same way, the public server will also be still be accessible. It still has access to the internet also, right? And if I access the private server also, you'll see that it has access to the internet. Now, just to make sure, right, just to confirm that it is indeed the private server is indeed accessing the internet through the NAT gateway, I'll show you a few things. First, we will confirm the IP address of this particular server, okay, of this particular server. And then you'll see that it will be the same IP address of the public NAT gateway, right? So if I just go to Google here again, all right, and I can select what's my IP address, and you'll see, so you see it will show my IP address to me. So again, this is the private server, guys. if you see, it says 13.202.8.247, which is exactly our NAT gateway's IP address. You see here, if I click on my NAT gateway, it shows the IP address is 13.202.8.247, and here also this is the server IP, right? So we are currently on the private server, and the private server also shows that IP, right? Now, just to confirm that it is indeed going through the NAT gateway again, what we can do is I'll just go ahead and remove the path from the root table, so that you'll understand that then it will not refresh the internet page. Okay, so I just go to the private root table and I'll remove this NAT gateway path itself, right? I'm removing this NAT gateway path. Now, if I go to the private server, it will not show me anything. Even if I access Google or something, it will not show, it will not load anything. See here, that means it was indeed going through our NAT gateway. Okay, so this is the importance of NAT gateway, guys. NAT gateway ensures that when you have a private server, private subnet, in that case, if you want to access the internet safely from within the VPC, from within the subnet, but you don't want anyone to access your servers from outside, don't want anyone to connect to your servers from outside, this is how you use your NAT gateway. You just go to the NAT gateway, you ensure that you connect your NAT gateway to your private subnet, you add the path, you do all that, and you will be able to access the internet. So I'll just quickly add that again and show that to you, that we will indeed be able to access it again. Now, if I refresh this private server page, you'll see that it will again connect, right? So this is the beauty of NAT gateway, guys. I hope you had a wonderful session. I hope you had a good time.